Hello all, welcome to Public Cloud Design Tips and Tricks again. Today's topic is as a part of design pattern, orchestrator pattern. The problem statement is how to control different software processes running together from a single component. Now, what is an orchestrator pattern? An orchestrator pattern works as a single point of contact to control multiple processes running behind a single dependency of controlling other sub-functions or processes. The control can be synchronous or asynchronous, and there could be an interdependency across the function call. So here in this simple example, if you see there is a user, it's using an orchestrator pattern, which is a single point of failure, and that will connect to service 1, service 2, service 3 running behind. Now there are different types of orchestrator design pattern, and let's start from function chaining. We'll slowly discuss what are the issues when you start developing this kind of types and how to deal with that. So what is function chaining? Function chaining is an example where it deals with a sequence of process or a sequence of operations. So there is an interdependency with the sequence of tasks. There could be a requirement to create a checkpoints in sequence in case of a failure of any one of the operation. Now checkpoints helps to manage the state of any data loss within this chain basically. Okay. So now if you see here, there are three Azure functions. I have taken Azure functions, Microsoft as examples. So there are three Azure functions. They are dealing with the different operations, and there are three queues, which is actually helping a intercommunication between the Azure functions. So, for example, fast Azure function is an operation will first send a message to Q1. Based on that message, the second Azure function will start operating. Once it finishes, again it send a message to Q2. Based on the message in Q2, the third Azure function will start operating, and finally it send the result to Q3 for further operations. So this is how a function chain gets established. Okay. But if you start writing this code of your own, okay, then what will happen? It will add more complexities handling multiple functions and queues. It add more complexity to handle error scenarios. Now that is where a durable function comes into picture. So durable function is an exact implementation of how to deal with orchestrator techniques within Microsoft. So what is a durable function? Durable function is an extension of Azure function, and it helps to develop stateful function in a microservice umbrella, and it handles the state management capability, error handling capability, and retry mechanism within itself. Okay, so basically durable function will provide all the background capability that is required when you start writing your own code to implement orchestrator design pattern. Okay, so now if you see in the same example, if you start using durable function, then it starts from a context. So context is used to call the function with a function name. Okay, and the context dot call activity will always give you a task object. Okay, so task object with a proper output, and the await will start waiting till the task gets completed. Okay, so those capability or those functionalities durable function provides upfront, and that is where, say for example, there is a operation going on within function 2, and there is a failure happens. Okay, so what it will do, it will always start from the end of function 1. So that is where it maintains the state basically, and the await function will always tries to wait till the function gets complete. Okay, so these are the capabilities durable function provides you to deal with function chaining. Now I have taken all these snapshot and examples from Microsoft sites, and I have already given the URL of Microsoft. You can always refer to that to get into it. Okay. Now the second time is fan out and fan in within Orchestrator. So what it is a kind of aggregation with fan in. Messages from one process gets consumed by multiple other process, that is called parallel processing here, and the aggregated results comes within with a fan in queue process by an aggregator. So here, if you see, there are three functions involved here, and the middle functions are nothing but it's happening in a parallel processing. So there are multiple instances gets created to consume the output from the first initiator function. So if you see in this diagram, there is an initiator function that actually sends messages to q1. Now the operating functions which is in the middle, it's actually start consuming the messages in q1, but in a different way. Here there are parallel processings going on, so there are multiple functions will start consuming the messages that is coming in q1, and it start processing those message. And once all the message process is completed or are completed within the parallel processings, then it will go to q2, and from q2 all the messages or the all aggregated messages will be consumed by the aggregator function, or the aggregator function itself will aggregate those output from the middle functions. Okay, so that is how fan out and fan in works. So what fan out here means, fan out means all the messages that will be triggering from the initiator go to into q1, there is a fan out, and once the aggregator happens, that will again push to q2, which is fan in, okay, to do the aggregation. Now the aggregated results comes with a fan in queue processed by an aggregator, and it is always complex due to dependencies again. Okay, so now with this durable function, you can very easily handle parallel processing. So what it will do, it will start creating parallel instances of the operating the middle functions basically. And it will, if you see here the list a task integer parallel task, so what it will do, it will start waiting for every functions that until they finishes. Okay, so until they finishes, it will start waiting, and then once that is done, then that finding process will start happening. So those capability durable function always provides to you, because when you start writing this kind of a coding, it's really complex to deal with this kind of parallel processing, and that will end you up with different kind of complexities. Okay, now the third one is async HTTP APIs. So what it does, it handles long running processes with external client actually. So when you have a dependency with external client to deal with long running processes, then this kind of design comes into picture. It uses HTTP endpoint trigger to deal with the scenario, and a separate endpoint to deal with the status using the polling mechanism. Okay, so if you see here in this example, there is a function who always triggers the operations. Then again there is a q1, there is a message comes to q1, and based on that message a endpoint gets triggered, which is the second operation function. So it takes the message and triggers the endpoint function. And what is the responsibility of q2 here? It actually tracks the status basically. So when the operation starts, probably a start operation start status, and then once the operation completes, it's completed, and in between there is some other status. Okay, so that is where q2 comes into picture. But the best thing is a separate endpoint redirection, which is the third function. It starts polling into the queue basically, q2, so get the status of the messages. So that is how it works as a whole. Now if you start using durable function again, uh, it has the capability to trigger and start the operation within itself, built-in capability to handle a long running processes, and a webhook redirection to poll the status of the operations. Okay, so it provides all the capability behind the scene basically, which is really difficult when you start writing the code yourself. Okay, so this is all about async HTTP APIs. Now the Fourth one is the monitor. So why monitor is used? It is used to get certain state of an operation. Here the operation is exposed to an API and API endpoint to get the state change information. Okay, so this is just a little bit reverse of HTTP sync APIs. So what it does here, the first operation, okay, the first Azure function in this example is try to call an API endpoint to directly get the status. Okay, instead of a redirection, it's directly talk to the API endpoint to get the status of the message. Okay, so this can be controlled by a time trigger or any similar kind of implementation where you can periodically trigger this capability to get the status. Okay, now this also can be handled using durable function. So in the durable function, it has all the capability to retrieve the status, and based on that, it can wait for that status and then send the alerts based on different scenario. So for example, let's say in your design you should want to wait till the status is completed. So durable function have the capability to do all the state management and waiting features till the status gets to a certain name or certain type. Okay, so that is where a durable function will try to help you. So, so these are the main four types of orchestrator design pattern that we normally come across, and Microsoft Azure always provides you a capability of durable function to deal with different kind of scenario based on your design, and to deal with different backend capability which is really required in you are dealing with this kind of orchestrator design problems. Okay. So if you want to get more into it, you always refer the link that I have been referring within the slides, basically, or within this topic from Microsoft to get more into it and to do a more deep dive into it. Okay. So that's it for the day. Thank you and have a good day.